Good morning or good afternoon, depending on your time zone. My name is Brian Morris, and I would like to welcome you to our webinar focusing on the integration of Zuken's DSCR electronics domain data management platform with Dassault Systèmes 3DEXPERIENCE platform. Today we're going to be demonstrating how this integration supports and enhances critical roles and provides new opportunities for its interdisciplinary teamwork within mechatronics product development. I would like to introduce you to our speakers today. As mentioned, my name is Brian Morris, and I am a project manager and senior pre-sales application consultant for Zuken, based in the UK, supporting the UK and Nordic regions. We also have Marion Mallard, who is Euro-West Technical Sales Innovia for Dassault Systèmes, based in France. Otman Anani, who is pre- and post-sales engineer for DSCR in Zuken, based in France. And Emmanuel Leroux, who is worldwide EDA systems strategy leader for Dassault Systèmes, also based in France. So what we're going to be looking at today, solutions that we're talking about. First of all is the 3DEXPERIENCE platform. Forgive me for reading from this, but it's probably the best way of doing it. The 3DX platform is a collaborative environment that empowers businesses to innovate in entirely new ways. It provides organizations a holistic, real-time view of their business activity and ecosystem, connecting people, ideas, data, and solutions together in a single environment. And you can see more on that at this website via this link. DSCR is the electronics arm of Zuken's DS2 mature cross-disciplinary engineering domain data management platform, and is developed in partnership with more than 3,000 leading companies worldwide. DS2 has evolved from an electronics data management product into a technology platform capable of managing electronics design data from CR8000, that's using DSCR, and electrical data from E3 series using DSC3. Both are embedded into their respective CAD-ECAD environments. Coupled with DS2, you'll also be seeing CR8000, or parts of CR8000 I should say, which is a suite of applications that span the entire PCB engineering lifecycle, from architecture planning through system level engineering, optimization, right through to physical implementation and manufacturing of the tools supporting that authoring process. How this all fits together, so this here is a typical IT infrastructure for engineering that we'd see in many businesses that we deal with. At the top here we have our PLM system, which in this case is our 3DEXPERIENCE platform, which we'll be dealing with today. And this is capable of model-based system engineering, product engineering, manufacturing and support as a holistic virtual twin. And that supports many disciplines across the life cycle of designs, from the MCAD design over here, which is generally very tightly integrated into 3DEXPERIENCE, particularly from the CATIA side of things. Also over here we'd have software management and software development, which is potentially managed by a PLM system, and various other things. Where we're focusing today is in this central section here, which is the world that Zuken occupies. And we occupy two systems here, which is the electrical side and electronic side. So on the electrical side we have the E3 series platform, and this is what we're talking about today, which is the CR8000 platform there, together with the domain data management, which is what we call our DSCR. So what we do with DSCR, we actually manage our own data, we have our own workflows, we can generate documents as you'd expect, and we pass on the information that is required to the higher level platform and interface for workflows and those side of things. So that being said, I'm going to pass on over to Marion and Otman to give a more detailed demonstration of the solution we've got.
Thanks, Brian. So our goal today will be to showcase this collaboration between the 3DEXPERIENCE platform and Zuken DSCR CR8000 of tools. And the following demonstration will rely on two use cases, which will be based on three main pillars. The first one is breaking the silos between electronical and mechanical worlds. The second one is having a single source of truth for your data. And the third is about winning time thanks to the virtual twins of your product. So the first use case is about component management, and the second will be about electronic design. So on the first use case, you can see on the screen, we will begin by receiving a component request, create and classifying the component, the electronic component. After, we will enrich it with component attributes. And then inside Zuken, you will open component from PLM, create symbol footprint 3D, save the component in the PLM, and release the component. Please launch the video, Atman. So I will begin with the three first steps. So receiving the component request, create and classifying the components, and enriching its attributes. So as component engineer, Steve Component, I have been assigned to a component request in which I got all information about what the electronic engineer needs. In that case, a capacitor of 3.3 microfarad, and I get the data sheet and all my tasks. So here I have a task is to create and classify the electronic components. So to do that, go in another widget to create an object, a specific object, so you can see that directly we have a specific object dedicated to electronic components. So I will create it, and I can add some attributes directly, but you will see after. So here the object is created, and then I will classify this object directly also in the 3D Experience platform. So to do this, I will just search the component and add it in the library. So with the new functionalities, you can now directly at creation, create and classify directly the object. So as it is my object, I can directly classify it, and I will have automatically all the attributes associated, which are attributes which are inherited from the entire classification. As you can see on the left, you have a classification which is based on different levels, which are hierarchical levels. So I can directly fill my attributes. You see the attributes are based on some categories, and this is where I say that the attributes are inherited. Some are for all passives, some are only for the capacitors, some are for only the fixed capacitors, etc., etc. It really depends on the class you classified your object. So it's really, you can really have dedicated attributes for each type of electronic component. Once my object is classified and the attributes are filled, I can come back in my component request and validate my task saying that I created my electronic component. So I need to put a comment to be sure everything is all right. And I can also add my related item inside the component request for more traceability. And I will let the hand to Atman for the rest of the demonstration.
Thanks, Marion. So at this point, the component request is created on 3D Experience and managed on 3D Experience. The electronic component is created, classified, and its attributes are fulfilled within the 3D Experience. Now, as an electronic engineer, I will continue to work on the ECAD environments to create the electronic ECAD components and send back the data to the PLM. Then we'll finish by releasing this component. So first we'll log into 3D Experience. And we'll see that Will Electronics, the electronic CAD engineer, will receive a notification with a component request created on 3D Experience. Then by opening this component request, we'll find that it is conceived with the many tasks, and this first task, the ECAD development, is attached to me, to Will Electronics, the user. Then by opening the task, we'll see that we have a data sheet and also the component already created. But by opening this electrical component already created, we see that we have the attributes already fulfilled, the necessary attributes to create the component on the ECAD environment. And we see that we have, for instance, here the capacitance tolerance, which is set at 10, the value of 10, and other attributes necessary and needed to conceive the components. Then we switch to the ECAD environment, to DSR. First, we'll start by fetching this component, this physical electronic component, to DSR using this functionality. We'll query manually the name of the component, and DSR will retrieve from 3D Experience the metadata and this part. We see that you have a PDM version, title of the component, and an ID and other attributes. Once this transfer is done, We can then go and edit our component. We'll open the component. We'll see the metadata and attributes already transferred from 3DEXPERIENCE to the SCR, and we see that at this moment the component has no CAD part attached yet. We have the attributes and the values fetched from 3DEXPERIENCE. We will then go and conceive the components within the ECAD environment using CR 8000 tool. So we will attach or create or attach our CAD part. In this case, we will attach an existing CAD part. We'll search for this CAD part C1206, and we find the CAD part. By selecting this part, we will attach this CAD part. We will attach it to our physical component. We can view, for instance, here the CAD part. Now it's a complete component with its package, footprint, and symbol. We'll open footprint and make a small modification. Here we open our footprint. So we can visualize our footprint designed on 1000 tools, footprint editor in this case. So we make a small modification and save our footprint. Same way, we will view our symbol. And make a small modification on this symbol. The same way, in this case, we attached an existing CAD part that fits and meets the technical specification of this capacitor, but the same way we can create a new CAD part and attach it to our physical component coming from 3D that we pulled from 3DEXPERIENCE. So now the modifications are done. Our physical electronic component is complete with its complete structure. We may need to adapt any attributes. For instance, here we'll adapt the tolerance value. Once these modifications are done, the ECAD development is finished, and the next step will be to send this component to the 3DEXPERIENCE. So now our component is completed, and we will open the component same way and send the components and the data back to 3DEXPERIENCE. Here we send the component attributes and the 3D shape of the component. Once this transmission is completed, we'll switch to 3DEXPERIENCE platform, actualize this electronic physical component, and we'll see that a structure of the component is created with the 3D shape. The component is at status in work, and we will switch to the 3D Compose app application of Experience to visualize the 3D model and 3D shape of this component. As you can see in the right, the 3D shape of our capacitor. At this point, the electronic conception and development is done. Electronic will log again into 3DEXPERIENCE and open the component requests and approves the ECAD development task that was initially assigned to him by specifying that the ECAD development is done. So finally, we will showcase how the approval flow is synchronized between the two systems, the SCR and 3DEXPERIENCE. For instance, here in this use case, the electronic engineer, I will go and request approval of the component on DSCR. This will change the status of the components from in work to frozen, as you can see. And finally, by sending this component back to 3DEXPERIENCE, we will see that the status is going to change also on 3DEXPERIENCE from in work to frozen. And finally, Steve, who initially created the component on 3DEXPERIENCE, will come and release the components on 3DEXPERIENCE platform. So here ends this first use case. To summarize, we created and we showcased how we create and we manage a component request on 3DEXPERIENCE, create a component, classify it and enrich its attributes, then transfer the metadata to DSCR, conceive the electronic component on DSCR, the footprint, symbol it, and fulfill or update the attributes, then send back the data to 3DEXPERIENCE and synchronize the approval flow between the two systems. I will hand over to Marion for the next use case.
Thanks a lot, Otman. So for the next use case, we speak about design management. So we have 10 steps on this use case. So the first one is to create the assembly and bareboard objects inside the 3DEXPERIENCE platform. After we will come back in Zuken, CR1000 and DSCR to fetch a PLM object to create the DSCR project, create the schematic, check in schematic and part list, do the part list initiation and transfer to PLM. After, we will do a bit of mechanic constraints while creating the bare board inside CATI. Then we will come back in Zuken to create the board outline and critical placement from the EDF generated by the mechanical engineer. We will save everything, document the 3D model and design inside the PLM. And at the end, we will check the product assembly and we will modify the life cycle of the entire product. So you can launch the video. I will just begin by the create assembly and bare board. So as an electronic engineer, I have a task which asks me to create a new bare board for the BME2 product. So I will create my assembly board, which is the specific object 2, and I will create under DSCR bare board. So it's a DSCR bare board because it can be used by Zuken after. And that's what Otman will show you just after.
So at this stage, the physical electronic, the physical assembly board and the bare board are created on 3DEXPERIENCE. As an ECAD engineer, I will continue on the on our environment and Zuken ECAD environment. We will start by fetching and importing the data from metadata from 3DEXPERIENCE, the same way as for the first use case. Here we'll view and fetch the assembly board. We'll specify the assembly board as a query option. DSCR will communicate with 3DEXPERIENCE and fetch all the boards available. For instance, here we'll select a flyback converter assembly board. It will come along with the bare board. We can see the same PDM version, titles, and all the attributes that are mapped between the two systems. And especially the unique ID, which is very important for us to track the objects. Once the transfer is finished, we see that on DSCR we have a complete structure that's created, containing a bare board design box, an assembly board design box, which will contain the bare board and assembly board documents, and also circuit parts list and PCB layout containers. We'll attach a circuit Same way we can create a new circuit, but in this case, we will attach an existing already made design of circuit design of the flyback converter. By viewing, we'll view this design and make small modification. And we can see our design circuit on design gateway. We'll go and change, for instance, this capacitor C13. We'll change the capacitor by a new part coming from CR 8000 library. Then we'll save our modification. So we check in the data, and now we have checking the data to take into account the new modification. And here we have a structure containing the circuit design, which is complete. After this, we'll go and create our part list. So we'll create a new part list. We'll give it a name, flyback converter. We save, and once we open the part list, we can then import our circuit data to import the component lists from the circuit design. So here we see the list of the components contained in the design with the necessary and all the attributes, part name, reference, etc. We save our modification, and so now we have a structure containing a circuit and a part list. We'll generate the documents just at this stage to generate the circuit data, the circuit documents. So we will generate a PDF of the circuit design and also a copy of the native circuit data. After this, we'll send these documents to the PLM. And along with these two documents, we are also sending the BOM, the part lists to 3DEXPERIENCE. So it can be used by the ECAD engineer in order to create the mechanical data. For instance, the ECAD engineer can go and take and place some of the components. So when you switch to 3DEXPERIENCE and refresh, we can see now that our assembly board contains 49 items, which are the components. They are attached to the assembly board, our bare board initially created, and also the documents just sent. So our schematic and PDF and copy of the schematic data. Here, to continue the layout design, the electronic engineer will need the mechanical data. So I will hand over to Marion to continue the creation of this mechanical data.
Thanks a lot. So here we will see how the mechanical engineer using 3DEXPERIENCE platform and CATIA tools will define the mechanical view of the bare board and generate the EDF file, which will be sent to Zuken. So to do this, I still have a task, but this time as mechanical engineer, and I need to create the mechanical constraints of the bare board in the product context. So here I will open my product. My product is named BIMI2, is a micro video projector. And I will see where I can put my bare board. So here I have my frame where I can put my board, my assembly board, in fact. And I will add the assembly board already created and used by Zuken. But you will see for the moment you do not have the layout. You just have the basic board sent by Zuken and all the components which are all at 0, localization. So here we will create a dedicated object to put our constraints for a mechanical bare board. So to create this bare board in the context of the product, we will sketch first the bare board. I created a rectangular view, and by managing the position constraints from the frame to the bare board. Once all the constraints are done, we can create the bare board layout. So the bare board layout is a real object which will be recognized in the EDF as the bare board thickness inside Zuken. So it's really important to have the right thickness. And then you will create your hole, which will be aligned to the hole you have inside your frame. Once to do this, you can create your keep out constraints. For example, the constraints where you will have the screws in this case, but it can be all type of constraints where you cannot put some components or where you can put components until small area or things like this. So this will be the free screw keep out areas. And then you can have everything which is ready for creating your outline, so the area where you will place your components. For here it will be the top of your assembly board. So you can see that inside one application dedicated to electronic conception, you can do all the bareboard conception in product context, and you will see after that everything will be supported in the IDF file as separated areas, which will be supported also inside Zuken. So here we have created our placement area where we can place our components on the top. We will also create here a specific area to create the power, to place the power supply. So in fact, as mechanical engineer, I know where the power cables are coming from. So I can say, okay, so the power supply connector has to be in this area to be sure that it can be connected easily inside the product. So I will not detail it, but we can also do this for the bottom of the bare board, of the assembly board. So this is the case here. And once we have done our constraints zone, we can check inside the entire design if it fits well and if there is no clashes. So here we will do a section of our product, including our constraints, and we can see that everything is fitting in the product and there is no clashes with the frame and with the other components of our product. Once we have done this, we can generate our IDF file to exchange with the electronic engineer. So to create it, we just have a small button. Yeah, we'll put the product back. So we will create the IDF of the entire board. So it includes all the constraints we created, but it also includes all what has been sent as part list by Zuken. So we select these and we generate our IDF file. So in the IDF, we see that we have all the components which were sent by Zuken, which we do not move because it's not our role. But here we have also all the constraints, the keep outs, and the place region we have created inside CATIA. So the file is saved on the laptop, and it's exported, and we will attach the file to the to a collaborative tasks for two reasons. The first one is to say that we finished our task and everything is done, and the second one is that it will inform also the electronic engineer that it can add this file directly inside the 3D Experience platform to improve the traceability and to be sure to have the right file at the right moment. So I let Otman continue to let you see how we open this IDF file, how we work with it, and how we create its layout and save it inside the 3D Experience platform.
Thanks, Marion. So here, as the mechanical data is available, constraints are available. So as an electronical engineer, we'll connect again to 3D Experience, and we'll see that there is a task assigned to me. And within this task, we'll find the mechanical constraints attached as an EDF file. I will download the file, the EDF file that contains the mechanical constraints for this flyback converter PCB. Then we switch to the ECAD environment and create our layout To do so, we'll generate the board from the circuit. So we will give it a name, save, and the board will be generated from the circuit data. So we choose our number of layers, the design rules to be applied. Then we generate our board from the circuit. We can see that the components are, the board is generated as a, by default as a square board outline, and the components are laid out next to the board on the top. Then we will import the real board outline and mechanical constraints from our EDF, which has been just downloaded from 3DEXPERIENCE platform. We can see now that the real shape of the board is imported, and we can see, for instance, 3 holes on the board and this power supply area designed to the placement of the power supply component, and some keep out areas that are designed to avoid placing components around the holes, screwing areas. And also we have the high limit areas imported to avoid placing components that exceeds these high limits, one on the top and the other one on the bottom, as we can see. So here, for instance, we will go and take our components, the power supply connector, and place it in the designated and specified area. We'll save the modification, checking our board, and we'll continue the layout design offline. So now the layout is finished, we will view our PCB. The result of the layout, we'll see that all the components, we see that the components are all placed and the layout is done. According to the constraints, we can also view that there is no component exceeding, for instance, this high limit area, and the placements area are respected. So at this stage, the layout of our PCB is finished. Layout designer has finished the work, and we can then generate the manufacturing data documents using the prepare document functionality, which calls the docgen functionality. It's a completely customized function on DSR. It's a configurable function. User can configure and set the documents that you would like to generate. In this case, we generate Gerber files, a step file, drill files, and also take a copy of the native PCB and schematic data. We'll do the same operation on the assembly board to generate the manufacturing files. So we generate again schematic PDF, EDF file, and copy of the native files. Once the manufacturing files are generated, then as an electronic engineer, will send these documents back to 3DEXPERIENCE. So here for the bare board, we sent 14 documents. If we switch back to 3DEXPERIENCE, we can refresh and see that our documents and manufacturing files arrived to 3DEXPERIENCE. So we have 14 documents along with the 3D shape, and everything is in work. All documents are still in work state at this stage. We'll repeat the same operation on the assembly board to send the assembly board documents, and along with the assembly board documents, we'll also send the BOM and the parts list for this assembly board. So to update the parts list with the new positions, because at this now the components are placed on the PCB, so they are transferred with the correct coordinates and positions on 3D Experience. So we see the documents also arrived along with this parts list, and they are in work state. Then the next step will be to synchronize, to approve our components. First, we'll send also the article bareboard. This is done to send the 3D shape for the bareboard, and also to update the attributes of the bareboard objects. We'll do the same for the assembly board to update the attributes of the bareboard in case we modified or corrected some or completed some attributes of these objects. Then next we will request approval of our documents and send them back to 3D Experience. So we send the documents for validation. By this way, we will change the status of our documents in DSR. So we request approval, and now they are frozen in DSR. And when we switch to 3D Experience, we can see that the status of our manufacturing files is also synchronized on 3D Experience, and it has a frozen status. This is done for the bareboard. We'll do the same for the assembly board. We request validation of our documents and send the documents for validation on the 3D Experience platform. So now the status, as you can see, is changed on DSR to frozen. And when we switch to 3D Experience, we see that the status of these documents is also synchronized on 3D Experience platform. At this stage, the ECAD development work is done. I will hand over to Marion to complete the use case and showcase the product validation and lifecycle modification.
Thanks a lot, Utman. So we will end these two use cases by speaking about project assembly validation and lifecycle modification. Let's go on. So as you have seen, we have the entire e-boom, so engineering boom, which has been sent by Zuken DSCR, and you can do directly inside the 3D Experience platform, so on web-based 3D model revision and visualization. All the 3D model has been done by the connector. So it's directly created by Zuken DSCR. You can also do a web design review to create a validation. So you can see that your assembly board, as it was already placed during the CATIA part, was already placed directly in your product, and you can see that it really fits inside the product. Now that everything is validated, you can decide to freeze your board. So really easily you will change the life cycle, and after you will also freeze the assembly board. And after you can also have these modifications available in Zuken DSCR. So thanks a lot for listening for these two big use cases about component management and design management for electronics. And I will at the end to Emmanuel Leroux for the printed circuit board analysis simulation.
Thank you, Marion. Thank you, Othman. So let's now jump to the simulation part. So basically, what we are going to talk about now is about the concurrent engineering we need to perform between the mechanical designer that is going to use CATIA, SolidWorks, but eventually also Siemens NX or PTC Creo, Zuken as an ECAD product, and also what kind of simulation we want to achieve. Will that be to check the quality of the signal on the traces of the PCB, signal integrity, and so on. And here, basically, we start in this case with a PCB that has been brought available, and Tom is an electronic engineer, is going to make a simulation. He gets a notification that new PCB is available for simulation. So it's going to select it from the 3D Experience platform and is going basically to visualize it and put the scenario. In this case, as the power distribution network is very important to avoid ground bounce because the power net is not ideal. He select the ground and the 3-volt VCC net and position an observation point on which you want to see the transfer impedance, which is basically the power integrity result. And you see at 1 gigahertz, there is a resonance and it's not good for ground bounce. Therefore, he check on the impedance map and try to see where you need to add more decoupling capacitors. And this is the red part over there. At that point, he's going to save his project and is going to inform the ECAD designer, her name is Sarah, she has to add more decoupling capacitor on that PCB project. As soon as she did it, Tom gets notified that a new project is available and does not need to set the scenario again. He just can import the new PCB version and just simulate. So this is the beauty of what we call ModSim, modeling simulation. You just get the result as a what-if analysis because you added more decoupling capacitor, and you can observe that you don't have resonance anymore. So this is really what we can achieve. So as you can see from that video, you are able to connect the mechanical designer, electronic designer, and simulation engineer in one basically platform where it will be possible to exchange a unique data model. So imagine you have a provider that change the value of the electric, of your epsilon. All the model will be updated at once. You don't need, to send a new step file, a new IPC file. Everything is managed with notification and you save time because after you simulated a PCB once, you can speed up the next simulation because you have already a simulation model ready. Thank you for your attention. Now I will bring the mic back to Brian.
Okay, thank you for that. We've got a few minutes left. There have been some questions coming through, which I've been answering as I've been going through. Just a couple of questions start from my side. As we were going through, the question sort of came about. I know in CR8000 we can handle variant designs. Is it possible to handle variant designs in DSCR? So just to clarify for people.
Yes,
So in terms of variant designs, we're talking about maybe components that may be fitted or not fitted, or even alternate parts. Can we support that in DSCR?
Yes, variants are managed within CR8000 and DSR directly in the design and PCB layout. So this approach allows us to maintain a single design and a single PCB layout and a single parts list with the multiple destinations. So when sending a specific variant, the corresponding variants documents are selected and the parts lists are adjusted according to the specific destination. This setup enables efficient management and adaptation of variants while keeping the core design and PCB unique within the SCR. So they are managed the same way as we have seen in this demonstration for the master assembly board.
Okay, thank you very much.
Just for you to know.
Sorry, carry on.
Sorry. Yeah, inside the 3D Experience platform, these variants are sent as result variants. So we will have one assembly board per variant you find inside the SCR.
Okay, excellent. So that sort of leads on to my second question, really. So I noticed that in the platform in 3DX, the assembly board is the master. That's your controlling article, if you like. In DSCR, it's the bare board is the controlling article. Can you explain the reason for this?
Yeah, for sure. So in DSCR, you will have one bare board which will be reused for several assembly boards. That's why you put the bare board in master and the assembly boards as a variants of this bare board. In the 3D Experience platform, we see it as engineering and then as manufacturing. So it will be the assembly board which will be not the master, but the container of the bare board plus the component as hierarchical view. And it will help to produce your manufacturing bill of material, which will be based on for production. So you will know that to produce your assembly board, you will need this bare board with these components.
Okay, excellent. Thank you very much. And just probably one question from me for Emmanuel, if that's okay. Thanks for discussing the power integrity via Simulink 3D Experience. Are other simulation tools available specifically from my point of view? Be interested in thermal or finite element analysis. Is this available through the connector and in the platform?
Good point, Brian. Yes, so thermal is key for electronic cooling. So yes, thermal simulation to get a thermal map of your PCB is achievable as well. And we may think about reliability simulation if we want to run a finite element analysis of your PCB with a so well-known technology of Abacus that we have embedded inside the 3D Experience platform. Yes, those two are the kind of simulation that's possible. And we may think about the co-design between the different, simulation domains to find the best compromise for your product.
Okay, excellent. Thank you very much. A couple of questions that came in that I've either answered or not answered. First of all, I had a question, are we going to record this? Yes, we are. The recording will be available and a link will be emailed out to everyone that's attended. So thank you very much for that. A couple of questions relating to the source data of the 3D shapes. The source data we typically use in DSCR in CR, I should say rather, is typically STEP. So we're talking about component models. Those can be sourced from anywhere from our point of view. It really comes down to your company's practice. They could be designed in this case and pushed out to CR8000. Alternatively, it may be that from a business point of view, you're happy to use step models and your component engineers are happy to use step models that are provided by manufacturers. So that doesn't really matter. The step models are held within DSCR and are pushed through to 3DX, and correct me if I'm wrong here, but Marion, but I believe we convert the step to CGI. And in Marion's presentation, you saw an image of the PCB with the components assembled on that. Just to clarify that is when we send the bare board in step. We send all the component positions, X, Y, and Z, coordination and rotations, and inside 3DX they have the CGIs that have been derived from the step models inside DSCR, and the board is reassembled inside 3DX. So that's how that side of things works. That's how that side of things works. Other questions we have actually had. I've got one from Hugh Griffiths. Can you use step format instead of IDF format for transfer? Yes, you can. As long as the step file that has been generated by your mechanical CAD tool is a step assembly, yes, we can dive into that step assembly and we can identify the PCB substrate from that, including critical placement of parts if need be. So there's a couple of questions that have been sort of raised around that. So it is possible to do that, to use the step model. Also, from a CR point of view, we are capable of using native CAD data directly. So yes, we can do that. Let me have a quick look through any ones that we can answer now or we need to. Yeah, I mean, if you have got any questions that we've not answered, I know that we've got one attendee, they've got quite a lot of questions and asked for a contact. So if you look at the screen, you'll see our LinkedIn profiles. Alternatively, I'll drop some emails out to you. You can use my email address, which is brian.morris@gb.zuken.com, or to reach us, or you can go via the Zuken support call. But we've got all of your addresses, so we can actually email you any answers that we've got. Okay, I've got one here. Which version of 3DX is needed for the functionality that we've been talking about today? Oh, that's been answered. Sorry. Yep.
So for today, we use the 23X FD04 3D Experience platform with 2023X.1 DSCR connector, and it's based because we have this installation in place with Otman to do this demonstration. But you can have this connection since 2022X 3D Experience platform on premise, and since 2024 XGA for the cloud, and with the corresponding Zuken DSCR connectors, so it can be 2022.1 or 2023.1 for 2024X FD04 3D Experience platform.
Okay, there's one question probably following on from that. You probably answered it, but I know my apologies if you already have. Is the connector available for 3D Experience on premise and public cloud?
Yeah, so yes, since this January, you can have it on premise or on the cloud.
Okay. Let's have a quick down. No other questions? Carol,
there was a question about DocGen, and so Search Porton is asking how do we generate IDs for the new documents. So for the new documents, they are generated within DSCR via DocGen without PLM ID. because they are still at that point. This video and what we showcase at that point, they're still not available on 3DX platform. But once we send the documents to 3DEXPERIENCE, they will be created and have a new ID. Then I will read the unique ID and fill it in this outside. So it's done during the send of the documents.
Okay, I think that's covered everything, and so we'll answer any questions that haven't been covered. And I think, Christian, you've asked quite a few questions, and you want direct contact, so I'll make sure that's available for you after the meeting. Okay, just about reached the end of our time now. I'd like to thank Marion, Emmanuel, and Otman for attending, and thank you everyone for attending. And please keep your eyes open for an email with the link to the webinar, and drop any emails to us as appropriate. Thank you very much.
Thank you. Bye-bye.
Thank you.
Thanks, everybody.
Bye now.